Okay, so what we've talked about so far, to kind of bring it all up together, is we've got the scatter plot, which we talked about a little bit yesterday. We talked about the positive, negative, no correlation, what we've done before. We did this one in our calculators. We did this one, which is our data set before. And we also did the experiment yesterday, correct? Right. So what we were looking at is we introduced something called your R value, okay? This is found under your linear regression line or linear regression on your calculator. And yesterday I talked to you about the fact that it's between -1 and +1, okay? And what we said about that was that if it's closer to the -1, right, like say -0.98, that's going to be a strong negative correlation, okay? And then, of course, going the other side, if it's a positive value like that, this is going to be a strong positive correlation, okay? And then, of course, we have that one thing that will happen to stand out. If you get a 0, that's going to be a no correlation. Okay, so even if you have like a -0.01, this is still a weak negative correlation. Okay, it's got to be 0 for it to be no correlation. Plus, it's going to be pretty obvious. Yep. Weak. Okay, so what this does for us, how about we do this? So from -99 to 0.75, let's just say that's strong, just to make it easier for you guys on your homework, okay? And then if it's between 74 to 26, and those are all still negative, we're just going to say that's a negative correlation, okay? And then anything below or closer to 0, this is going to be a weak negative. And if you switch the numbers around to being positive, it's going to be strong positive if it's between 99 and 75. Positive correlation between these numbers and a weak positive. Okay? Does that make sense? Okay. All right. So all this right here does is when we look at the R, is when we come into our scatter plot like this guy up here, and in algebra 2 or algebra 1, wherever you guys did this, we just had to make you say, okay, just find 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. We said just make the line so that it goes between, so you have the same number up top as you do on the bottom, like that, right? And then I think we even made you guys find the slope of it and that type of thing through 2 points, that type of thing. So what we're going to talk about today is making sure that we can put that in there, and I'm going to show you how to store that equation into your equation into your calculator. Okay. Okay. So first thing we need to do is I need a data set. Do you guys still have your data set from that problem from yesterday? Have the data set from the handprint question from yesterday, right? Does anybody not have it? Okay. So my data points are from our question a couple of days ago when we were doing the sprint and the long jump, right? Okay. And so if we go to here, we go to calculate and go to number 4, and you can see, right Everybody has, pull that up there on your calculator real quick. Good. All right. So if you enter down to the store regression, your regression equation, right? What you're going to do is I want you to hit not the second or anything like that. You're just going to hit vars. Okay, so you should see that window, correct? Okay, so then you're going to move over to y vars, and we want function. So you're going to hit enter on the function, so you should see that. Okay, see how that says y1? Yeah, hit enter on that. So you guys should see, once you hit y1, you should see that. Is anybody not seeing that? You gotta go data set on y1, go down to calculate. And so it's just going to bring up what we saw yesterday, right? Obviously, mine's going to be different because I have different data sets. So if I look at my R value right here, it's a negative correlation. Your guys' is positive. Okay. So now here's the crazy thing. If I go to stat plot and I just plot that scatter plot like we've done in the past, I just go down here and say graph it, you should already see your linear regression line come through. Anybody not see it? Just hit graph or stat plot, excuse me. Make sure that's all entered in, that you're in the right spot, and then you hit graph. Was the fact that if on my graph, if I ran a 0 40-yard sprint, I could jump 414 feet. Okay. Now, the problem with that is that that is called an extrapolation. Okay. Outside our data set a prediction. Okay, so the great thing about this is an extrapolation is if it is pretty close to our data set, the prediction is pretty reliable. Okay, but again, you're going to want to use your common sense understanding of, hey, this is outside of it. This would be an extrapolation, but it's pretty close within our data set. Here's what we think would happen. Okay, but kind of like that long jump, you know, if I put a 0 in there, you know, it's really not going to affect that much. Okay, now an interpolation is just when we use a value inside our data set to make a prediction. And this one is reliable as far as our data set's reliable. As far as the data set is reliable. Okay. All right. So, speaking of reliable data set. Would you say that our scatter plot, how about scatter plot, is that resistant to outliers? Well, let's think about it. Who had that really weird height yesterday? Somebody said, "Are you sure you measured me correctly on their height?" Okay, so what did he say about yours? About your height? He measured you wrong. How wrong? You're off by 10 centimeters. Short or long? Was he short or was he long? Okay, so if you think, you guys have data set right here. Haha, that was close. So here's somebody's data points, correct? See, I hid their name, so it's okay. If you come into here, where were you at? 192? So you're right out here, right? So you really should have been where? To the left? Okay. Is it right if I write on your paper? Okay. That's all right. I don't want, sometimes people get mad at me. So if we move this over to where it could be, right? And we ignore that data point, visually, I know it's kind of hard to see, but you can see how moving that point inwards makes the data set look a little bit more positive, a little bit stronger. Makes that correlation together a little bit closer, right? So when I ask the question, is our R value resistant? You would say, no, it's not. So our correlation value, which is our R value, is not resistant. And so when I say it's not resistant, that means that if we have an outlier, or if it becomes an outlier, it will affect the relationship, the correlation. Okay. All right. The crazy thing is, if you, let's see here. Let's say one student has X as the height, and then the next one has and Y as the hand span, and then you have hand span, and then you as a student have it the other way around. Just swapping those two around like that, the graph will look different, right? But your R value will be the same. Okay, which I think is pretty cool. Remember, we're only going to use this for quantitative data values. No, what's it called? Quantitative. What's the other data type? If you have quantitative and I think I call it categorical. Okay. And I got to stop it because we're going to run out of time. Use curved because it's not linear, and there's your homework.